TCP timers is the next part. So TCP uses several timers to ensure that excessive delays are not encountered during communications. Several of these timers are elegant, handling problems that are not immediately obvious at first analysis. Each of the timers used by TCP in examination in the following section, which reveals its role in ensuring data is properly sent from one connection to another. TCP implementation uses 4 timers. So there are 4 timers. TCP is using retransmission timer, persistent timer, keep alive timer, and time wait timer. So retransmission timer, to retransmit lost segments, TCP uses retransmission timeout RTO. When TCP sends a segment, the timer starts and stops when the acknowledgement is received. So acknowledgement, once it is received, it will start and stop. If the timer expires, timeout occurs and the segment is retransmitted. RTO, retransmission timeout, is for 1 RTT. To calculate retransmission timeout, we first need to calculate the RTT, that is the round trip timer. Next is the persistent timer. To deal with a 0 window size deadlock situation, TCP uses a persistent timer. When the sending TCP receives an acknowledgement with a window size of 0, it starts a persistence timer. The persistent timer goes off. The sending TCP sends a special segment called a probe. This segment contains only 1 byte of new data. It has a sequence number, but its sequence number is never acknowledged. It is even ignored in calculating the sequence number for the rest of the data. The probe causes the receiving TCP to resend the acknowledgement which was lost. Keep alive timer. A keep alive timer is used to prevent a long ideal connection between two TCPs. If a client opens a TCP connection to a server, transfers some data and becomes silent, the client will crash. In this case, the connection remains open forever, so a keep alive timer is used. Each time the server hears from a client, it resets its timer. The timeout is usually how much? 2 hours. If the server does not hear from the client after 2 hours, it sends a probe segment. If there is no response after 10 probes, each of which is 75 seconds apart, it assumes that the client is down and it will terminate the connection. So if there is no response after even 10 probes, which are sent at a 75 seconds apart, means one probe is sent, after 75 seconds the next probe is sent. So if there is no response from the client side, then it assumes that the connection is terminated. Time wait timer. This timer is used during TCP connection termination. The timer starts after sending the last ACK from second fin and closing the connection. After a TCP connection is closed, it is possible for the datagrams that are still making their way through the networks to attempt to access the closed ports. The quiet timer is intended to prevent the just closed ports from reopening again quickly and receiving these last datagrams. The quiet timer is usually set to twice the maximum segment lifetime, ensuring that all segments still heading for the port have been discarded. So this is the question which can come for 5 marks, that give a short note on TCP timers. So all this we have to write, and all we have to explain all the 4 timers.